Okay, so with compound and double angles, what you want to keep in mind is you won't necessarily have to cram your formulas because they will always be on your formula sheet, right? And your formula sheet for me is almost as good as your calculator. You know, the same way you never want to do maths without your calculator is the same way you never want to do your grade 12 maths uh, without your formula sheet, especially trigonometry, right? So with our compound angles, so these are our compound angles, right? And as mentioned, you don't want to cram these because they are always on your formula sheet. And what I've written down may not be 100% what's on your formula sheet. You may have sine and cos maybe swapped around or anything like that. However, it's basically always going to give you the same value, right? So these are our compound angles. You only have 4 of them. You don't necessarily have any for 10, especially now in grade 12. However, if you do see anything that looks like this, right, you want to remember that as long as you're working with 10, you can always split that into sine over cos, right? Exactly. And this will also be the same if you have your angle plus another angle, right? So that's for 10, right? We said these you won't get on your formula sheet. However, the idea is to always remember that anytime you're dealing with 10, you will always be able to split it up into sine over cos. And remember, these individually can be expanded using your compound angles. Okay. So when we deal with double angles, right, you want to keep in mind again that your double angles are always on your formula sheet and you also don't necessarily need to cram them, right? Our first set of double angles will be ones for sine, right? So the main key thing is that you always want to keep in mind that anytime you have a formula, you're able to use it from left to right or from right to left, right? As in, if you're given something like this, you're able to expand it into something like that. If you're given something like this, you're able to compress it into something much smaller, right? And the other big issue that I've noticed is that people tend to forget that anytime you have a value for alpha there, this may not necessarily only be one single thing. This can also be even maybe like 2 terms or anything like that. So what I mean is if alpha is not one thing, right? It just means if you expand your double angle there for sine, whatever this value is, it's going to be the same there and it's also going to be the same there, right? So keep in mind that your value for alpha is just a placeholder for something that may be on its own or for something that's slightly a bit more aggressive, right? So another example that I can show whenever you're dealing with double angles is if we find ourselves with something where this is, let's say, a multiple of 2, right? Something like this. We want to keep in mind that if we're going to perform any calculations with something like this, we may want to split this value up, right, into 2 times 3, right? And then something like this, we can expand that using our double angle formula, right, for sine. Something like this would easily look like, right? So key thing is, again, going back to our main formula, right? Alpha will not always be one single thing. Alpha can sometimes be 2 terms, and alpha can, where alpha is specifically, can also be maybe something that is not on its own, right? But the format you want to look out for is again a value for 2 in front of an angle, right? Here we also have a value for 2 in front of an angle, right? And whatever this angle is, we're able to throw it together with sine and we're able to throw it together with cos, right? And this is not limited to alpha. As we know, this could have been any value, maybe like beta. We know that it's just a placeholder, right? So the next set of double angles that we have is ones for cos, right? So what you want to keep in mind is, again, remember the last few that we wrote down here. This is not like other new formulas or anything like that. It's not like something on your formula sheet per se. What is on your formula sheet is this main one, right? And here we were just explaining how you want to think of alpha as just a placeholder for something else. Okay, so for cos, right, we know that with cos on your formula sheet, you have three formulas, right, that cos 2 alpha is equal to, or rather you have three formulas for the double angle of cos, if I can put it that way. So the main one, right, that you will see is this one, right? The other two basically come from your square identity, right? So the other two, I'll just jot them down and then we'll explain where they come from, right? And we'll also explain why this is the main one, and then the other two, they just come from you making use of your square identity to manipulate it in such a way that you end up with those two formulas, right? So we mentioned that for our double angle for cos, we have three tiny formulas, right? So the one other issue, right, that we also want to clarify is that you don't want to think of these as like three formulas that are standalone. This is actually your main formula, right, for your double angle for cos. These two come from so we know that with our square identity, right, if we take sine over to where 1 is, we will have cos squared being equal to 1 minus sine squared, right? And then vice versa, if we take the cos squared over, we know that sine squared is equal to 1 minus cos squared alpha. So the main idea is, for example, we mentioned that this is our double angle, right, for cos, and we know that this is its main identity, if we can put it that way. So the key thing is that we know that if we were to replace, for example, cos squared alpha, right, if we replace cos squared alpha with like 1 minus sine squared alpha, we would end up with 1 minus 2 sine squared alpha, right? So we know that this is the main one, and then for them to get this third one here, all that was done was they replaced cos squared alpha with 1 minus sine squared alpha, right? Same with this one, right? We see that where we see sine squared alpha, right, sine squared alpha can be written as 1 minus cos squared alpha. So if we replace sine squared alpha with 1 minus cos squared alpha, we end up with cos squared alpha minus 1, right, which is our other identity for cos 2 alpha. Right? So the main reason for us laying this out is to just give us the idea that with trigonometry, especially in grade 12, it is something that is very dynamic, right? So in the sense that depending on what you're given and depending on what you need to prove or depending on what you need to show, you want to be very comfortable with being able to juggle around, especially with whatever it is that's on your formula sheet, so that you can answer whatever question that they will be asking you to answer. So for our first example on compound angles, this is what we have, right? They want us to write this as a single trigonometric term, right? So what we can already see is there's definitely something going on here. There's some form of pattern, right? We can see the first pattern that we could identify is there's a sine here and then a cos, right? And then here there's a cos and a sine, right? Furthermore, we can see that here we have 2x plus 40, x plus 30, right? And then again 2x plus 40, and then x plus 30. So that on its own will definitely remind us of a compound angle expression, right? So what we could visualize for ourselves, right? So remember we mentioned that on our formula sheet we have quite a few compound angles, right? So what we have here, right, should remind us of something in this form. So the key thing to take away from this is we can see that where alpha and where beta is, we won't necessarily only have one single term or one single value there, right? We have cases like this where we have something a bit chunky and then also something a bit chunky there. So as long as we can see the trend, this will still stand, right? Like whatever we have here is somewhat in this format. And we know that according to our formula sheet, right, anything in this format is a compound angle, which is equal to sine alpha minus beta, right? And we know that as long as we have identified that this is in the place of alpha and this is in the place of beta, we know that if we were to pack this up into our compound angle, we would end up with something like this, right? Where alpha is, right, we know that we have in our case a 2x plus 40. Where beta is, we know that in our case we have x plus 30 there, right? So we know that if we were to clean this up, this is what we end up with, right? Our main question was asking us to write what we were given here as a single trigonometric term, right? So all we had to do was to identify that this is a compound angle that is expanded, right? And as soon as we have identified that, we know that on our formula sheet we have something that looks like this, and we can easily just pack our angles according to this formula, right? Where we have alpha, we can see in our case we have 2x plus 40. In this case we have x plus 30, which is where beta is. If we just clean that all up, we know that we end up with sine x plus 10 there.